Okay, today I'm going to be talking about calorie cycles regulations and how they pertain to the production of compost to ensure that it's safe for the public health and the environment. First off, I won't go into too much detail in this slide, but California has made it clear in its desire to reduce the amount of waste being disposed in landfills and to put that material to a higher and better use. Starting back in 1989, with the Integrated Waste Management Act to the most recent legislation of SB 1383. SB 1383 at its core is a statewide effort to reduce emissions of short-lived climate pollutants, which includes methane. California's landfills emit 20% of the state's total methane, which is a climate superpollutant, 85 times more potent than carbon dioxide. The statewide goal here is to reduce the amount of organic waste being disposed by 75%, as well as rescue 20% of the edible food by the year 2025. So for us, that's just right around the corner. So this is going to be a huge change in the way we manage our waste in California. For some quick numbers, just over half the waste being dumped in our landfills is considered organic waste. This includes the 34% labeled as organic on this pie chart, and that is made up of yard waste, food waste, and manure, as well as the 17% from the paper category. This in total equates to approximately 22 million tons of organic waste. Now, there are a couple of technology options available to process this material, including anaerobic digestion and traditional recycling, but we are still estimating that composting will need to process an additional 10 million tons, which is a pretty significant increase over the current amount of 6 million tons being composted annually. Using some rough numbers, composting 10 million tons of material with a 50% mass loss during the process equals about 5 million tons of finished product with a bulk density of about 2 cubic yards per ton. This equals 10 million cubic yards of compost, typical application rate of 10 cubic yards per acre. So California has the potential of applying compost to an additional 1 million acres of land each year. So how will we make sure all this collected material is safe? This slide shows an example of typical incoming feedstock and how it looks. At the bottom of the image is food waste, which contains a pretty significant amount of contamination. And the large pile in the back is what is defined as green waste, although it does look brown in the picture. All right, first off, what is composting? It is a biochemical process that takes time, meaning weeks or months, not days. People who promise a machine that can make compost in days are not actually making compost at all. It simply can't be done. A succession of microorganisms drive the composting process forward. To do this, they need the food, which in this case is organic waste, water, and air. Take away any of those elements, and the composting process simply will not happen. The microbial action of composting generates intense heat. Bacteria dominate the early stages of the composting, but as the process moves along, different types of fungus take over. It's the fungi that facilitate the breakdown of the woodier materials. This generally happens during the curing phase after the pile begins to cool down. Many composters try to make finished compost in about 8 to 10 weeks on the commercial setting, which is pretty fast. However, a well-matured compost generally takes a little longer than that, especially when you're putting in food waste, which has a lot of embedded energy in it, so that can keep the pile active and hot for much longer. In California, there are two main types of commercial composting, which have slightly different regulatory requirements. Pictured here in this triangle-shaped compost pile, it's being mechanically turned to allow air and as well as adding moisture to it at the same time. Um, Water is not usually added so elaborately like it is here. It's usually done by a water truck on piles like this, but I thought this turner was pretty cool, so I had to show it off. This type of process is known as open windrows. Um, these two facilities here are not the same, but it's what a typical site would look like from above. Historically, this has been the primary way to compost, but due to changes in the permitting um, for these types of facilities, we're not expecting to see too many more of them constructed in the future. We will, however, expect to see more aerated static piles or ASP systems, which are pictured here. These types of systems are a lot more expensive on the front end, but there are also a couple of advantages to this type of technology. The material is not required to be mechanically turned and is much easier to apply water, which can add up to a significant cost savings over time. The footprint is about half the size of an open windrow facility, and the covers can be made of different materials. One you'll see on the bottom left there is made of done by the Gore manufacturer, so it's similar to a Gore ski jacket that you would have. And then there's other types up in the top right, but it can also be done with finished compost that is 6 to 12 inches thick, which we call a compost cap. The greatest benefit to this type of system is that it significantly reduces the emissions coming from composting operations. For a quick explanation on that, as I explained at the beginning, composting significantly reduces methane, which is a potent greenhouse gas in comparison to landfilling. But the decomposition of organic materials, no matter where they are, produce volatile organic compounds, or VOCs for short, and as well as other things like ammonia and NH3, which are considered criteria air pollutants, which are precursors to ground level ozone. Therefore, using a technology like ASP here significantly reduces these emissions by at least 80%, which is a huge advantage over the traditional open windrows. Pathogen reduction. This is the process known as PFRP, the process for further reduction of pathogens. It is based on the US EPA's 503 standards for biosolid composting, but in California, it is applied to all composting. PFRP must be performed for all materials in a compost facility, and the monthly inspections done by local enforcement agencies almost always include inspection of these temperature logs. For very large facilities, there are specialized thermometers which enter the data directly into a specialized software package that helps them keep the numbers in order. The bottom line here is, if the piles are not getting over 131 degrees for the required time, they will not pass. Composters are also required to test their end product for 2 pathogens, Salmonella and E. coli, and the 9 heavy metals listed on the slide. There's nothing to stop them from testing for more compounds, and frankly, they usually do. They test for all the major and minor nutrients, NPK, calcium, sulfur, magnesium, etc. This all gets included on one laboratory analysis sheet that has become fairly normal on the composting scene. Additionally, as of 2018, inert contaminants must also be tested for plastic and glass and things like that. Must be verified to be less than 0.5% of the finished product. And of that 0.5%, no more than 20% of that may be a film plastic larger than 4 millimeters. So yielding clean finished compost that is free of contamination is ideally done by ensuring that the feedstocks received by the facility are not collected with the contamination in the first place. This takes a lot of communication and education between the haulers, generators, and local jurisdictions, which can often be an uphill battle. Once the feedstocks have been received with contamination, it's up to the compost facility to manage it. The equipment to clean up the material can often be quite large and sophisticated, but the industry has recognized the importance of making sure their final product is clean of things like pieces of rigid plastic, film plastic, glass, rocks, cement, all that. So to distill down the process flow, as trucks come into the facility, they will always visually inspect each load to make sure that it does not contain large amounts, as the truck's coming in, to see if they need to reject the load. Once the material has been unloaded, they will often hand pick out all the large pieces of contamination before the material is placed into the composting system. Once the material has finished the composting process, the facility will employ various equipment to clean it up. Here's just two examples of the equipment and how large it can be. The one on the left here is a pretty specialized piece of equipment that separates out the plastic, the inert contaminants, as well as the final product. And just another example of how large this equipment can be and the importance that facilities are putting on cleaning it up. And okay. And as a closing, this is just a summary slide of CalRecycle's composting regulations and what a compost facility's responsibilities are. In short, a facility must inspect their incoming loads for contamination, ensure the composting process meets time and temps for effective pathogen reduction, and testing the final product to ensure it is safe for the public health and the environment. And with that, I think we'll be taking questions in a few minutes, but if you would like any further information on anything I showed here, here's my contact info.
Great. Thanks, Brian. And I just have one quick clarifying question, just for myself and the audience. So this program applies to large-scale commercial compost producers, but if someone was composting on their farm, kind of small scale, these don't kick in, or am I?
No, that is correct. Everything I talked about is for commercial composting in California.